electrical safe isolation checks on boilers. My name's Alan Hart, and in today's video we're going to show you how to do your safety checks on a gas boiler when you're working on a gas boiler. This is a request from in our trading group on Facebook, and Paul, who works, he's a Worcester Bosch engineer, and he's done us a nice video to show you how what tools, what equipment you need and how to use them as well. It's a very detailed video. If you've got any questions, please ask them below, and yeah, let's go and have a look. This video is for gas safe registered and trainee gas engineers under supervision. Please comply with the current regulations at the time.
Just going to show you here some bits of kit what I use for doing the electrical tests. So I'll show you how to do electrical tests properly, do them in depth. First one that we use is a digital multimeter. If you're not sure of the settings, I can do another video on a multimeter and testing and your results and whatever. But basically it'll read ohms, resistance, alternating current and direct current to tell you the readings, what you need to find when you're working on your boiler. They come with two probes, and normally what you do is that when you test with the multimeter, you test your probes first. You put your probes both together and you test your probes and you test the resistance of your probes, which is what you call the base reading. So when you get your base reading, put your probes together. Some multimeters show a base reading, some don't. Mine's showing 0.2 ohms, which shows you that's just the resistance of the fuses in your actual unit. So obviously if you're doing continuity testing, and say for instance your reading is, for sake of argument, 2.2 ohms, if you're doing a continuity test and you're getting 2.2 ohms on your multimeter, that's your base reading. In other words, you are getting continuity, but there is different readings which you get, which I will go into more depth with. The next one you've got is a voltage tester, which will tell you the true voltage of something. Comes with your red probe and an earthing probe, but you do always go earth first, then to your live component. Don't do it the opposite way around. You could short things. You know, there's nothing saying that you will short things, but always go earth first, because that way you're protecting yourself. If you go earth first and you touch a live component and it trips, your hands will be free. Sorry, your hands won't be free. So there'll be no way that you can come into contact with electricity. But always use your earth first. It's always good practice to test to your earth first. Next is a non-contact voltage detector. What that does is that will tell you, without even touching the boiler, if it's live or not, or any live components. As the old saying goes, you prove that the unit's working, you use the unit, then you prove again, so that you know that the stuff that you're using is actually working. Not much point putting it on a test and then you find that it doesn't work, because you could be putting your hands into something live. So always work safely. The last piece of kit I use is a proving unit. Basically you can prove something which you know is live. If you're unsure if something's not live or not, you can use a proving unit. This is a powered unit, 9-volt battery inside it, and you can test your testing equipment with it. Normally use it to test a voltage tester on that. You use your proving unit just to test that, so that you know that your stuff's working properly. Always ensure you use a proper kit for every job which you're doing, and make sure that it's all calibrated and in date and working properly. If not, do not start work. Okay, first test I'll do is with my non-contact voltage detector. They all differ. This one is one I got from Plumber. It's a pretty good one, made by Raptor. It's got on-off button. When it turns on, green tells you that it's on. You press and hold the green key, it will put a light on it if you want to go into little dark places. Quite useful. It's also, if you press the green button once, who go on to sensitive. Goes on to a sensitive reading, so you can use more low voltage testing. But for this purpose, just go on to normal non-contact voltage detection. And basically, you've never seen this boiler before, never touched it before. Don't touch it. Use a non-contact voltage detector. Check all the way around the case. It's painted, so it's insulated really. This bit's plastic, so not much point testing that. But test around the case. But also, very important, test the metal components go into your boiler, and test the chassis underneath your boiler. If you don't test these parts, they may be live and you may come into contact with them and touch them. You've got to make sure that there's no way you can get a shock from it. And to test a positive source, I'll test the fuse spur of the boiler, which I know is working and it's on. As you see, it indicates there's a voltage, so we know that this unit's working. Test everything again. So any metal part that you're testing around the boiler, test the chassis as well, touch the chassis. It's not showing me a reading. I'll test it again. It tells me that my test is okay. I'm okay to carry on touching the boiler because my non-contact test is passed. So I can touch the boiler with no fear of getting an electric shock. Now I've removed the fuse from the boiler. Some people do it differently, but I always choose to put it in my pocket. So 3 amp fuse is in my pocket. What that means is that I've got control then. Unless somebody comes in, beats me up and puts me in a bad state and puts the fuse in without me knowing, then I know that the 3 amp fuse is in my pocket and that no one can turn the electrics onto the boiler. So basically it's a pretty straightforward one. Now to do your checks on this boiler, there's 4 checks you have to do. The first one is an earth continuity test. Second is a short circuit test. Thirdly is a resistance to earth test. And the fourth one, which is a live test, is a polarity check. I'll show you how to do the dead test first. The first 3. It's quite simple, not too daunting, and it'll tell you a lot of things before you can proceed with work. But these are the proper electrical checks you should do on a boiler. Now with your multimeter, you can do it with the multimeter or a voltage tester. I'll show you the multimeter way first. What you do is that on your multimeter you've got different settings. You've got, here is the resistance, which is the ohms symbol. You've got alternating current. You've got direct current. The rest are all different things which you can measure. Some are micro amps and things like that, which you can do to test things like, for example, a thermocouple. You can test the resistance of a thermocouple if you wanted to. But this multimeter which I've got, it's a pretty basic one. For your short circuit test, resistance to earth continuity test, it needs to be set to continuity or ohms or resistance, whatever you want to call it. But you should have an open line. When your 2 probes are separated, you have open line or infinity. That means that they're not in contact and that the actual reading is infinity. There's no way that they can touch unless you bring them together. So that's the reading you want to start off with first. Test your 2 probes together. You should get a resistance reading of your fuses inside your probes, inside your multimeter. That's them both touching there. Getting a reading of 0.2 ohms. So that just tells me the resistance of my fuses. So when I do my test, and if everything's okay and I've got continuity, in other words there's a link between them both, then I know that I'm safe to work. Especially with earth continuity, if you're testing your earth from your boiler to your earth of your whole house system, and you're getting anything other than continuity, there could be a short circuit somewhere. Short circuit could lead to, obviously, electrical problems, cause it to trip, lots of different things. So we'll test earth continuity next. Earth continuity testing. Right, to test the earth continuity testing on this boiler, you need to go from the earthing bar of the boiler, which is just there. If you can see all the earth wires going to there, they're like a metal strip. That's the earthing bar of the boiler. Now the way that we test the earth is to test from the earthing bar and test to the pin on your fuse spur, because normally they are linked up, tested to the earth of your whole house system. So to put this into practice, we'll test from the earth pin of our fuse spur to the earthing bar of our boiler. Okay, testing earth continuity of the boiler. I've put my probe in there on the earthing bar. I'm going to go to my socket screw of my fuse spur and check the readings on my multimeter. As you can see, it's showing 0 ohms continuity. If I take the black probe off, I'll have an open line. Put the black probe back on again on my earthing pin, I've got continuity again, base reading of the fuses on my multimeter. So I know, okay, the boiler is earthed properly to my house's earthing system. So that's the earth continuity check. Checking from the earthing of your boiler to the earthing of your whole house system. That's the first dead check that you do. Checking a readable resistance on the boiler, or short circuit test. What you should do is, you should test from your live, just here, across all your neutrals, and that will tell you if you've got a short circuit or not. You should be having a readable resistance in ohms. So open line means that there's a break, there's nothing connected because my probes aren't currently touching. Yep. Now if you test on a short circuit test and you've got continuity, like your base reading on your multimeter, there is a problem. That means that live is finding a path down neutral, shown by evidence of arcing normally all the way around your components. Looks like your fan plug, your pump plug, all the way around your circuit board. Any sign of scorching or like electrical marks would show you that you're having a short circuit somewhere. Something's touching. It could be two wires which are melted together on the fan. Check things like your fan plug, check things like your pump plug, anything which doesn't look quite right. Let's say if something's got wet on your plugs, for example, on any component of the boiler. Best to check it when it's dead than rather when it's live, because you don't know. But doing this test is the way to know that you've got a short circuit on some components somewhere. So you'd set up with your live probe first, probe fitted to the live. As such, you test to your neutral on your boiler, on the neutral plug there. I'm getting a resistance of 302, 303 kiloohms, which is perfectly fine. If you find you're getting the base reading like 0.2, just the base reading of your meter, it's finding continuity. In other words, it's getting a path or a current to something. So that wouldn't be correct. If it's open line, it means that something's broken. So you test your neutrals on your boiler. Make sure it's got a readable resistance. If it's open line or it's continuity, there's something wrong. So that's your short circuit test on your boiler. Next test will be a resistance to earth test, which is testing from between live and earth. Now you certainly don't want continuity on this test, because continuity between live and earth would be a live to earth fault. It would trip out, should hopefully blow your 3 amp fuse. If not, should blow your fast blow fuses in your circuit board, which is this little fuse just there. That's your fast blow fuse. So what would happen is that if there's any fault, it would then blow the fuse, hopefully. Then if not, your 3 amp system fuse, stop any electrical damage to your boiler. So with your pin on your earth, you test live to earth. So you test on your live pin, and you should have, your reading should be open line. In other words, there's no way those 2 wires are actually connected. You should get a reading larger than 1 mega ohm, which is 1,000,000 ohms. So obviously you've got to make sure that that is the correct reading. If you're thinking, oh, there's something wrong, I've got open line, don't think that. Open line is correct. Open line is the best reading you can get on a resistance to earth check. Make sure that your live and your earth are completely separated, so there's no path down the earth from any live current when the boiler's in operation. Right, the last electrical check is a live test. So obviously, safety first, things to bear in mind. Do not touch any components inside here. There is certain mats you can buy, electrical mats, which you can put over insulating mats, which are quite good. Some firms actually ask you to use them, some don't. But basically, it's a pretty straightforward check, long as your hands are free. What you do, you put your fuse back into your fuse connection unit, shut that off, turn the boiler on. Boiler's in operation. Now, because I've only got one hand free really, you put your tester onto voltage alternating current, because in this country we use alternating current, so you test at alternating current. So the first test you got to do is test between your earth. It's already on my earth pin, so you test live to earth. Should be getting a reading of 240 volts around about there, or depending. Got 238 volts there. Next test you do, you test between your neutral and earth. You should be getting a reading between 0 to 15 volts alternating current. You're thinking, why am I getting 0 to 15 volts? Reason being, that's called electrical impedance. In other words, electrical inductance. That means that because the live earth and neutral wire, they have live earth and neutral running through them, it creates electric field. So the electric field, a slight small amount, will actually pass through into your neutral core. Doesn't mean it's directly connected, it just means that it's reading that. So between neutral and live, as is on the boiler just there, you'll get 0 to 15 volts AC. Your last test is you test between the neutral and live. So I'll test between neutral. Excuse me while I just put my probes on. Neutral and live on the boiler, should be getting 230 volts AC, which is correct. So that tells me that my live polarity test is correct. There is variations on this test, as in reverse polarity. Reverse polarity is not a good thing for boilers. Some boilers will still work with reverse polarity, but the one problem which you've got there is that the neutral is powered and not the live. So what happens there is that you would have no fuse protection on the fuse spur, because the current is passing down your neutral. So if it's passing down your neutral, it would go through the boiler, through you. If there's a problem and you're getting a shock, it wouldn't blow the fuse. The reverse polarity is a very important one to bear in mind. Also, certain boilers will not rectify properly without the neutral being connected properly. On a Baxi 105 for instance, you're wondering why a Baxi 105 will fire. it won't stay lit. Do a quick electrical check, could be your neutrals the wrong way round. It's quite a simple check, but that's the electrical checks concluded and tells you that everything is fine and in safe working order with this boiler. So I'm alright to continue, and I'll show you how to do the service on the CDI.
I'd just like to say that this is just a guide. This video is just a guide, so thank you to everybody who's watched it. But what I would advise is please go on a training course. So there's lots of manufacturers that do electrical safety courses. This video is just so that if you've been on a training course and you sort of forget, then you've got a little bit of knowledge there to help you. So always be, always be safe, always make sure that you're safe, and electricity is obviously very dangerous. So yeah, if you've got any questions, please ask them in the comments below. And if you're a trainee and you're training to be a plumber, come over to our group on Facebook, and and we're happy to help. And if you need any videos or anything like this, again, just ask, and we'll try as best to do what we can with the time that we've got available. So yeah, thank you for watching.